Hi, everyone. Welcome to the Energy Storage Market Series. Today, we're going to be hearing from Tony Vernetti, sales trainer at Enphase. But before we dive in, and while we're letting everybody kind of filter in here, for anyone who hasn't heard of RENVU before and maybe just got our email for this webinar, give you a quick brief overview of RENVU and some of the things that we offer. So my name's Nick. I'm a sales engineer here at RENVU. RENVU was founded 2012 and based out of Mountain View, California, although we do have fulfillment centers on the West and East Coast as well as in Texas, so we can generally hit all of the United States within a pretty reasonable time frame. Our entire sales team has an engineering background, which allows us to go pretty in depth on projects ranging from small residential DIY projects up to larger commercial. So we can help you out and be that sort of first line of defense. As well, we offer a lot of other services, including permitting, as well as design tools on our website. And jumping forward, I'll give you a quick look at one of those design tools, the Solar Kit Guide. So it's a system designed to be able to let you put together a bill of materials for your project relatively quickly, within 5 minutes, by just answering a few easy questions. So here you can say grid tied or off grid, microinverters, string inverters, choose the panels from what we have available, or you have the option to put in your own specifications for panels. All the while as you're going through and choosing the roof interface, the layout, it's giving you a full bill of materials on the left there and updating as you make changes, giving you information about the DC system size, the AC system size, as well as all the individual components you're going to need for your project. If you're logged into your account, you'll actually see pricing, as you can see here on the left, so you can get a rough estimate. If not, you're just doing it for the first time, it'll generate a quote under a generic account and email it out to you, and then give you the option to log in and take a look at pricing for different products. But again, very easy, answering just a few questions, and you can always call in and talk with one of the sales team members to get an idea of any of the components that you maybe aren't familiar with. As you're going through too, one of the nice things, it gives you a racking sketch to give you an idea of what the layout's going to look like as you're putting it together. As we get in here later, choosing in the inverter options, there's also options for adding in energy storage, as we'll talk about today, to your system, adding in other components such as, so here we go, as we're choosing different microinverter options, the Enphase, choosing energy storage to add into it, and then add-ons such as permitting, whole home energy monitoring, things like that. So there's a lot of really great options inside there for putting together a bill of materials and getting a quick quote on a project. As well, we wanted to talk about our commercial price list and our energy storage price list. So here we've got our energy storage, so you can get an idea of the different products we carry, how they compare to one another, for something that might fit specific to your needs. And as well, commercial price list if you're working on larger projects. We update this regularly with all the different products that we're carrying and able to provide for different large commercial projects with pricing tiers and estimated delivery timelines. And both of those can be found on our website to get an idea of what's available, what you might be able to use. Great. So that's the end of my part here. I'll go ahead and kick it over to you, Tony. I'll stop sharing my screen and I'll let you go ahead and kick everything off on your end.
All right. Thanks for the introduction, Nick, and thank you, RENVU, for having me participate in this training today. It's always great to have the opportunity to do these kinds of sessions where we can do a great Q&A at the end and make sure that all of your questions about our products get answered. So just give me a second to share my screen. All right, Nick or anybody, can you just confirm that you can see the screen that says selling Enphase Storage now?
Yep, we're all set.
Okay, great. Okay, so let me step back. So yeah, the focus of today's session is going to be about selling Enphase storage. So we're going to talk about a lot about the features and benefits of the system. We're going to go over all the different components and how they work together. And we're going to do a comparison to typical AC coupled systems, so you kind of get an idea of how we compare to the major competitors out there. I'm just going to actually turn my camera off for this part, and I'll turn it back on at the end here. Just a little bit about myself. I was hired as a sales and product trainer by Enphase at the beginning of the pandemic, literally in March of last year. So I've been working remote the entire time, which has been interesting. You're all familiar with that, I'm sure, too. I live in Monterey County, and I got my start in solar in San Diego, which is where I'm from, in 2008. And over the last 12 to 13 years, I worked for 4 different solar contractors and a solar water heating system manufacturer as well. So I've seen many different perspectives of the industry. Most of that time I've done residential and commercial sales. And then when the Tesla Powerwall came on the market, I was working for a company that really hit that as hard as they could. And we were selling a lot of Powerwalls right from the get-go. That's kind of where I cut my teeth on energy storage. And since joining Enphase, I've been focused on the sales certifications. So if you do decide to go through Enphase University, which I really encourage you to do, you can get certified as a salesperson in Enphase Storage, and nice little feather in your cap thing that you can add to your email signature and let customers know that you've taken the time to learn, about products at a deeper level than your typical salesperson. Okay, so kind of touched on that. So let's start with the Enphase Storage value proposition. Enphase Storage was developed with one primary goal in mind, which is maximum reliability. And we believe that we've achieved this goal with our tried and true distributed architecture of microinverters in both the solar PV system and in the battery storage system. Since emergency backup power is the #1 reason people invest in battery storage, the system must work without a hitch with minimal effort by the homeowner every single time it's needed. So in this today's webinar, we're going to review the many ways that Enphase Storage does this better than other systems on the market today. Enphase pioneered distributed architecture in residential solar with microinverters for solar panels. This approach to solar was a game changer due to the immediate and obvious benefits to both the homeowner and the installer. Enphase systems produce significantly more energy than those with string inverters, and individual panel monitoring provided visibility of system performance that had never been experienced before by solar installers. The superior reliability of Enphase systems was also apparent due to the elimination of the string inverter, which was a single point of failure in conventional systems. It was natural for Enphase to use the same microinverter technology in the battery storage system. As with solar, the use of microinverters and distributed architecture in the battery units provides redundancy and improves the reliability of the system, ensuring that the owner has backup power when they need it most. Typical battery storage systems often have a single inverter, so a failure of that inverter would result in total system failure. An Enphase storage system will normally have at least 12 microinverters integrated with 3 or more battery units. A failure of 1 micro or 1 battery won't disable the entire system, but rather the power output will be slightly reduced until the microinverter is replaced. For example, if 1 of 12 micros fails, the battery will still be able to deliver 92% of its rated power. A battery with microinverter technology is like having a backup for your backup. Enphase Storage is designed to be modular, and it's suitable for homes of all sizes. There are 2 battery capacities available, a 3 kilowatt hour and 10 kilowatt hour, and they can be easily combined to tailor the system size for the specific needs of the owner. A home which requires backup of only essential loads like refrigeration, lighting, and electronics might just need 1 Encharge 10. A homeowner may want to add more storage in the future as their family grows and their energy needs change. Just add more Encharge units to the existing system. A large home with air conditioning and a well pump may require backup of all loads and could use 4 Encharge 10s. No matter what the requirements, the Enphase storage system can be customized to meet their needs. Most energy storage systems are built from components from different manufacturers, especially the solar inverters being different from the battery system manufacturer. If there's a problem with a system, it can be very difficult to diagnose and fix. We've heard lots of stories from installers over the years about how manufacturers often blame the other components for the problems. And this is a huge headache for installers. It causes you to run around in circles trying to get the answers you need. Enphase storage components and software are designed from the ground up to work perfectly together. Not only does this mean better performance and control, but if there ever is a problem, it's very easy to diagnose and fix with our sophisticated monitoring system, Enlighten Manager. If needed, Enphase customer support is available 24/7 to assist. In summary, the solar and battery storage hardware, software, monitoring, support, and warranty are all provided by one company, Enphase Energy, which will give your customers the peace of mind that they're looking for in an emergency power backup system. The Enphase Enlighten app puts total control of the system into the palm of your hand. Since all components are from Enphase, the app will have solar generation and energy storage monitoring and control. You'll know exactly how much energy is on hand, and with energy consumption monitoring, you'll also be able to see how you're using power, and you can make informed decisions to get the most out of your system and increase that period of autonomy when you're disconnected from the utility grid. You can also easily change the smart profile, which is the operating mode of the battery system, from full backup to either savings mode or self-consumption, depending on what the preferences are. If the system owner lives in a region where the utility grid is shut down frequently due to storms, they can turn on the Storm Guard feature, and this will ensure that the system will automatically be set to full backup if a storm is approaching, which could potentially disrupt grid power. Over-the-air updates keep the system current with the latest firmware, and it enables us to actually add new product features as they sometimes are released. Enphase Storage provides a seamless backup power experience for the homeowner with zero downtime, without even a flicker of the lights if there's a grid outage. It's a fully automated system, so homeowners don't even ever have to lift a finger to turn on backup power or to switch back to being grid connected once the grid is back up. Now let's review the key components of the Enphase storage system. There are three main components to the system. The Encharge storage units, which there are two sizes, Npower Smart Switch, and IQ Combiner. The IQ Combiner actually houses the communication devices to send data to the online monitoring system and for the storage components to talk to each other wirelessly. And all Enphase storage systems will also have Enphase microinverters on the solar array. Our system is not currently compatible with other non-Enphase solar inverters. It all starts with the Encharge Energy Storage Systems with integrated IQ8 microinverters. There are two versions of the Encharge. The Encharge 3, which has a kilowatt hour capacity of 3.3 kilowatt hours, and the Encharge 10 with 10 kilowatt hours of capacity. The Enphase storage system is an AC coupled energy storage system, meaning that there is DC to AC conversion both at the solar array and at the battery system. Each Encharge battery unit has multiple integrated IQ8 microinverters, which provide redundancy and improve the reliability of the system compared to other storage manufacturers that just have a single inverter. The battery chemistry of the Encharge is lithium iron phosphate, or LFP, which is a safer and more stable lithium-based chemistry than typical lithium-ion batteries like NMC, or nickel manganese cobalt. Since LFP battery chemistry is inherently safer, the Encharge units have a passive cooling system with no moving parts like pumps or fans. No moving parts means fewer fail points compared to other systems on the market. Encharges have a NEMA 3R enclosure rating, which means that they can be installed indoors or outdoors. Typically, they're installed inside a garage or on the wall of the home, which is not exposed to direct sunlight. You might notice that the Encharge 10 looks a little bit like three of the Encharge 3s in a row connected to each other. And that is in fact the case. That's how the system comes. The Encharge 10 is simply three of the 3s with a single large cover over the entire unit. The modular nature of having two Encharge sizes makes it easy to expand the system in the future as well. For most systems, a minimum of one Encharge 10 is recommended, and then additional 3s or 10s can be added to customize the system to size to meet the specific energy and power needs of the homeowner. The warranty is for either 10 years or 4,000 full cycles, whichever comes first, with a minimum of 70% capacity retention. To put 4,000 cycles in perspective, if the battery was completely cycled, meaning totally discharged and fully recharged every single day, it would take almost 11 years to reach 4,000 cycles. So this battery and the chemistry that we use is really designed for heavy use. For your initial sizing conversation with a customer, it can be helpful to present 3 pre-configured options. A single Encharge 10 is suitable for many partial home backup scenarios, which include a refrigerator, small 120 volt appliances, and other small plug loads. One Encharge 10 can power most loads that are connected to a 20 amp 2-pole circuit breaker. For whole home backup scenarios, at least 2 Encharge 10 units is recommended. This system can start and run up to 4-ton air conditioners and 3 horsepower pumps, provided soft starters are installed. Most appliances wired to a 40 amp 2-pole breaker can operate with 2 Encharge 10s. And then lastly, if you have a large home that has multiple large loads that must run continuously and simultaneously, that's when you are getting into a larger system size like 3 or 4 of the Encharge 10s. Proper system sizing needs to account for concurrently running loads, startup surge, which we'll cover in more detail in the next few slides, as well as the desired period of autonomy, or the number of hours that the system needs to support the home when disconnected from the grid. The nPower Smart Switch is the equivalent of the Tesla Powerwall gateway, and its primary job is to disconnect the home from the utility grid in the event of a grid outage. It's classified by the NEC as a microgrid interconnect device, and it's a required component for any of our systems that are providing backup power. If there's a grid outage, if there is a grid outage, it disconnects within 12 to 15 milliseconds, extremely quickly, and the microgrid is instantly formed by the Encharge batteries. The response is so fast that clocks and devices typically don't even need to be reset, like microwaves. Then, once the utility grid is back up, it detects the frequency and syncs to it for a very smooth transition back to being grid connected without flickering lights. The nPower can be used as either a whole home backup or a partial home backup disconnect. It has a built-in neutral forming transformer, which is required in order for the system to support both 240 volt and 120 volt loads. And just like the Encharge batteries, the enclosure rating is NEMA 3R, so it can be installed inside or outside. Up to 4 of the Encharge 10 units, or any combination of 3s and 10s that equals that, can be connected to a single nPower for a total of 40 kilowatt hours of energy storage, which is about 15 kilowatts of continuous power. The IQ Combiner houses the Envoy gateway, which sends information to the cloud for monitoring and control of the system. It also houses a cell modem, has a backup internet connection in case the home's network loses power during an outage, and a communications kit, which allows the Envoy and the storage components to communicate wirelessly. So not all IQ Combiner models include a cell modem. So if you're retrofitting a system with storage, which doesn't already have the cell modem built into it, all you have to do is purchase that separately and install it into the IQ Combiner. And here we have the communication kit. So this must also be installed in the combiner. It's always a separate item. And there's a spot right on the dead front of the combiner box to attach it, and it plugs into the Envoy with a USB cable. Enphase Storage is currently compatible with any solar PV system which uses Enphase IQ series microinverters like the IQ6 and IQ7, as well as M215 and M250 inverters. The M215 came out in 2011, and most of the systems between 2011 and when the IQ6 came out will use one of these two models. Now let's review some of the benefits of Enphase Storage. First, let's go over the different smart profiles or battery operating modes, if you will. First is full backup. Full backup mode should be selected if the main concern of the owner is having backup power during a grid outage. Enabling this mode will hold all of the battery storage capacity in reserve to allow the maximum period of autonomy in case there is an unexpected grid outage. Select savings mode if the customer wants to maximize their savings by using energy stored in the battery during times when the electricity rates are highest, typically called the peak period. In savings mode, you can decide how much of your system capacity will be held in reserve for backup power in case of an unexpected grid outage. The third smart profile option is self-consumption mode. Choose this mode if you want to use as much of your own self-generated energy as possible. The battery will charge whenever there's excess solar PV production, and then discharge whenever the home is using more power than the PV system can produce. Self-consumption mode is best if the utility provides little to no credit for energy exported to the grid. Just like with savings mode, in this mode you can also select a reserve capacity in case of an unexpected grid outage. And whether you're in savings mode or self-consumption mode, you have the option of enabling Storm Guard. And as I said earlier, Storm Guard is going to automatically switch the battery system over to full backup mode if there's a reasonable chance that a storm or other weather conditions like fires are going to threaten the area and potentially disrupt the utility grid. And then Storm Guard will automatically revert back to the previous selected smart profile once the threat from that storm or weather event passes. When it comes to the energy capacity of a battery, what are you really paying for? It's not the capacity on day one, it's the amount of energy you can put into and pull out of the battery over the 10+ year life expectancy. All batteries degrade in terms of their capacity with regular use. LFP chemistry, which we use in our N-Charge batteries, degrades at only about half the rate of NMC, the chemistry of Powerwall and LG Chem. So over the lifespan of the battery, you're going to get a lot more throughput of energy with an LFP battery. This graph shows us that after 2,000 cycles, the LFP battery will still have about 90% of its original capacity. By comparison, NMC batteries degrade to 90% after only about half that number of cycles. LFP battery chemistry is inherently less susceptible to fires caused by thermal runaway. When it comes to safety testing, Enphase has gone the extra mile by obtaining the UL 9540A listing. This listing means that the Enphase Storage battery cells, battery modules, and the N-Charge battery system have all been tested to ensure that a thermal runaway event does not result in catastrophic fire. No other major home battery storage system manufacturer has obtained this UL listing. Now we're going to talk about a unique feature to Enphase Storage called PowerStart. This is a powerful technology for the purpose of improving the resiliency of the battery backup system when it's grid disconnected. It detects spikes in power demand, which could potentially cause the battery system to shut down, and it smooths them out over a little bit more time to help keep the microgrid up. Significant power demand spikes occur when certain types of appliances with motors first start up, such as pumps, air conditioners, sometimes large fans and refrigerators can even be problems. In this example, the motor's normal operating power is 960 watts. But when it first starts up, it uses 5,760 watts, about 6 times more power for a second or two. Let's look at what would happen if there was a demand spike without PowerStart technology. The dotted line represents the maximum peak power output of the inverter of the battery system. Normally, the instant the demand exceeds the capacity of the inverters, the microgrid collapses and the customer experiences a blackout. The PowerStart algorithm detects demand spikes in a fraction of a second, and if the power demand approaches the peak power of the battery inverters, it reacts by instantly lowering the voltage, which in turn reduces power consumption. It's akin to a brownout, but on a very small scale and only for less than a second. And this really helps large appliances that have these large inrush currents start successfully with a smaller battery than you'd expect. How can we quantify the impact of power start on the system's ability to start appliances? Through extensive testing, we've determined that power start effectively increases the power output, or rather, to be more specific, increases the peak power output by approximately 30% over the peak power. So here you can have, we sort of do a side-by-side comparison. On the left is one Encharge 10 plus a 3, which is a 13.4 kilowatt hour system. And on the right is a 13.5 kilowatt hour system from a competitor. So as you can see, the rated power is around the same at 5 kilowatts. The peak power is around 7.5, but the effective peak power of the Encharge system is about 30% higher than that because of the effects of power start. Here we have a case study which illustrates the benefit of power start technology. A customer had a popular storage system from another company with 2 of their storage units. They had a large pump with a very high demand spike, and this proved to be too much for the system to handle, and the microgrid would collapse every single time the pump attempted to start. Now, why did this happen? The pump startup surge was 19 kilowatts, but the battery peak power was only 14 kilowatts. The peak power wasn't even close to enough to handle the startup surge of the pump. This inadequate system was replaced with an Enphase storage system with a slightly lower peak power output of 13.4 kilowatts. But with power start technology, it was able to keep the power consumption below this threshold when the pump started. So it was able to successfully start the pump and keep the microgrid stable. One last note about this comparison. The other system would have required a 3rd battery unit to be able to start this pump. That system would have had a capacity of 40 kilowatt hours, which is 74% larger than the Enphase storage system, which could start the pump. Now I'm going to talk about a feature of Enphase storage called load control. The benefit of load control is that it improves system resilience and increases the battery life during outages, or to be more specific, it increases the period of autonomy during grid outages. So it allows you to actually wire 4 individual loads or even sub-panels into the npower smart switch. And to be specific, you're not actually connecting the power through the npower smart switch, but you're connecting a control wire. And then those loads can be automatically disconnected if the system goes into grid disconnected mode or backup mode during a grid outage. It's also very configurable, so the homeowner or the installer has the ability to restore power manually from the Enphase app to any one of these electrical loads, or, like I said, even a sub-panel. It can also be configured to power specific loads based on the state of charge or how much energy remains in the battery. So this can be useful if someone wants to run their air conditioner in the afternoon to cool their home down, but they want to make sure they don't completely deplete the battery. So for example, once it gets down to 30%, power can be disconnected from that appliance. And then on the other side of the coin, once the system is recharged by solar the next day up to a certain level, then power can be reconnected to that appliance. And then lastly, it's also able to power loads based on the status of the generator. We're going to touch on generator support in a minute, but basically if the generator is running, you can set it up so that appliance will have power. And then if the generator is not running and not helping supply power to the system, then power can be disconnected. So this is a feature that was added fairly recently to Enphase Storage. It does require some additional components and wiring, but the functionality and the control aspects, which are done through the Enlighten app, are all there and active. The next feature we'll talk about is solar circuit control. So this is actually done with the same, essentially the same way that load control is done. And the advantage is that you can install any size solar PV system with a small battery system. So as you might be familiar with other systems, there's a maximum amount of solar power that you can connect to a given battery, because that during a grid outage, that battery needs to be able to absorb all the power that's coming down from the PV system. So if there's too much power, it can overwhelm the battery inverters and cause instability and blackouts. Various manufacturers have different guidelines. Our recommendation is 1.5 to 1 of ratio of solar AC power to storage AC power for maximum stability. Now, the advantage of solar circuit control is that you can go above this ratio because you can effectively use load control to turn off part of the solar array. So you could have a much larger PV system, and when the system goes into backup power mode, becomes disconnected from the grid, you can shed part of the PV system so that you maintain this ratio. So only you have this 1.5 to 1 ratio after the grid is after the system is disconnected from the grid. So this is a great option for you that have where you have customers that want a large PV system because they've got a big electric bill to offset, but they don't necessarily want a huge battery system to go with it. They might just want one Encharge 10 just for their essential loads. So this gives you that option. And then once the system is reconnected to the utility grid, that portion of the PV that was turned off is automatically going to be restored. Just as an example of the limitations with that 1.5 to 1 ratio, so with a single Encharge 10 installed, normally the maximum number of IQ7 plus microinverters that you could install would be 19. So again, with solar circuit control, you can go well above 19 as long as it's configured so that that portion of that solar array is turned off so that when they're disconnected from the grid, only 19 of the IQ7 pluses are active. Lastly, we have power control systems. So the advantage of power control system is that it helps avoid costly upgrades and additional hardware by controlling the amount of electrical current flowing to the main panel and the utility grid. Many AHJs approve the use of PCS, so I recommend checking with your local AHJ before you plan on using PCS. PCS works by measuring electrical current flowing from the storage system to the main service panel in real time, and then precisely controlling and limiting the current to a pre-configured safe level. When using PCS, when you do the NEC 120% rule calculation, you only need to account for the PV backfeed and not the storage backfeed. So this can allow you to actually install a small solar and battery storage system on a 100 amp service panel, which would normally not be allowed. And there are two additional benefits of PCS. Jumped ahead accidentally. Oh, there, keep going back and forth. Okay. The other benefit is that it can avoid utility transformer upgrades by limiting power exported to the grid to the power of the PV system alone. So there are some circumstances I've heard, especially in the East Coast, where utilities will actually ask customers to foot the bill to upgrade a transformer just for the sake of installing PV and storage. So with PCS, if it's if the AHJ approves the use of it, then you can, again, limit the current and avoid that transformer upgrade. And then second is a requirement that's specific to California utilities. So if you're not in California, you can ignore this next part. So you can avoid installing what's called a net generation output meter, or NGOM, which is normally required for battery storage systems that are over 10 kilowatts in power capacity. So that can be a huge money saver. Usually it's around $2,000 to $2,500 in total cost when you factor in the hardware, labor, and administrative costs of the NGOM. Okay, lastly, I'm going to touch on generator support because this is a feature that's coming out soon, and the way that Enphase does generator support is pretty sophisticated compared to other companies. Typical configurations will use an external automatic transfer switch or even a manual transfer switch, which allows either the solar and storage system or a generator to power the house, but not at the same time. When a battery gets to a low state of charge, it'll automatically switch the home's power source to the generator, which is going to continue to power the home exclusively by itself. So the generator is going to power the home until the utility grid is back up, even if there's enough sunshine to power up the PV and the storage system. This means that the generator could run for many days, burning lots of fuel and causing a lot of unnecessary wear and tear. Enphase storage generator integration eliminates the transfer switch. The generator is tied directly into the npower smart switch. The generator, battery storage, and solar PV can all operate simultaneously. With all three power sources operating together during a grid outage, the home will have the combined power to start and run large electrical loads. For example, a homeowner could run their AC or their electric dryer only during the day when all three power sources are operating, and then conserve energy at night when running only off of battery power. Please note that simultaneous operation of the solar PV and the generator is only supported with the IQ series microinverters like the IQ6 and IQ7. This feature does not work with the older models, the M215 or M250s. The generator could even be used to charge the batteries if the PV system isn't able to do so. This is a great feature for homeowners who require backup power at times when the PV system isn't producing much power. For instance, when there are cloudy skies due to storms, or perhaps hazy skies from wildfire smoke. The generator can be used to charge the batteries during the day so that the home can run off the silent battery storage system at night. It's important to keep in mind that eligibility for the federal tax credit may be impacted by charging the battery with a non-renewable resource. When a generator is combined with solar PV and battery storage, you're going to have a robust solution capable of powering a home through extended power outages with or without consistent sunshine. Now we're going to do a comparison of a few features between Enphase and typical AC coupled systems. A big benefit of the all-in-one system of Enphase is that the storage system can precisely control the power output of the solar microinverters so that the solar PV system will always stay on during a grid outage. And this isn't the case with other systems. All battery storage systems must be able to curtail the power output of the solar PV during a power outage, even with a maximum ratio of 1.5 to 1 that we discussed earlier. If the battery is full and the home is using little power, the power from the PV system has nowhere to go, and it could cause instability in the microgrid, and the battery system could shut down. With Enphase storage, if the PV system needs to be curtailed, it's precisely adjusted to perfectly match the power demand of the home. Enphase controls the solar output like a dimmer switch versus an on-off light switch. The battery remains fully charged until the solar PV output declines and then battery power is needed for the home. The main benefit is that the home will have a full battery when the sun goes down, and therefore a maximum period of autonomy to keep things running all night long. Typical AC coupled systems curtail solar PV power by sending a crude signal to the solar inverter called frequency shift. This is interpreted by the solar inverter as an unstable utility grid, and the response of the inverter is to turn off. The problem with this approach is that with the solar PV system shut down, the battery is the sole source of power, and it's going to begin to drain. Once the battery's state of charge goes down to a certain level, the solar will be allowed to turn back on. Depending on when the solar turns back on, the homeowner may be left with only a partially charged battery to power their home through the night. Obviously, with a partially charged battery, they're going to have a shorter period of autonomy and could run out of juice before the sun rises the next day. Enphase storage does rapid auto recovery in the event that the microgrid gets overloaded and shuts off. There may be times when the power demand of a home overwhelms a battery storage system, even with features like Enphase Power Start. In these situations, an Enphase storage system will automatically attempt a system recovery within just 2 seconds of the collapse. And if unsuccessful, it'll make repeated attempts with increasing time intervals. Once the power demand of the home is within the capabilities of the system, the recovery will be successful. This approach works because often the appliance which caused the overload will be off and won't restart immediately when the power is restored. Rapid system recovery turns the lights back on quickly so that the owner can easily resolve the issue by turning off circuit breakers to large loads or turning off the thermostat. Typical battery storage systems don't have an auto recovery capability. If they shut down due to a microgrid collapse, they must be manually restarted, and the recovery takes 5 minutes or more. Lithium-ion batteries generate heat when they charge or discharge, whether that's LFP or NMC. To keep the battery temperatures within a safe range, they have built-in cooling systems. Since N-charge batteries have a safe and stable lithium iron phosphate chemistry, the simple passive cooling system can be used. Convection draws cool air from below the battery and warm air exits the top. No moving parts are required for this system to work. So again, no moving parts means keeping the number of fail points in the system to an absolute minimum. Typical AC coupled battery systems use more common NMC chemistry, which has an inherently higher susceptibility to thermal runaway and fire. To ensure safe operation, they typically have active cooling systems with liquid coolant, pumps, and fans to enable rapid cooling when needed. These additional moving parts increase the number of fail points in each battery. The cooling system actually emits about 40 decibels of noise, similar to a large refrigerator. So locating the battery opposite a bedroom or other quiet space isn't ideal. So let's review a summary of the key differences between Enphase storage and typical AC coupled. First, multiple microinverters provide redundancy and eliminate the inverter as a single point of failure. Enphase storage can fine-tune the solar output so solar always stays on and the battery stays fully charged. The passive cooling system eliminates more fail points and operates silently. All-in-one support from Enphase storage, so you're going to have all-in-one support and warranty from Enphase. The UL 9540A listing for safety, which Enphase has and nobody else has. Advanced integration with generators, which allows them to operate together with solar and storage for maximum power and the ability to charge batteries with the generator. And then load control for multiple circuits, even sub-panels, compared to other systems which can typically only control a single thermostat-controlled load. Okay, now we're going to talk a little bit about sizing storage. So proper sizing of battery storage for backup power should accomplish 3 goals. First, it ensures that the system has enough energy storage capacity to power the home for the necessary period of time. So energy determines how long it will last. Next, it ensures that the system will have enough power to run the home's loads continuously. And lastly, it ensures that the system has a high enough peak power to start up appliances with high inrush current, like air conditioning and pumps. If your system design achieves all 3 of these, you're going to have a lot of happy customers, a lot of referrals, and very few service calls. For more accurate sizing, Enphase has a free web-based tool called the System Estimator, which can be found on our website. With this tool, you can accurately size an energy storage system to meet the specific energy and power needs of the customer. You can adjust the quantities of different appliances and their specific electrical characteristics like their power, surge current, and number of hours they need to operate. The System Estimator recommends a battery size, and it also tells you which key factor or factors is determining the minimum size, whether it's energy, power, or surge power. Using this tool with a homeowner will give them added confidence that you're going the extra mile to ensure that the system is going to work properly and it's not going to get overloaded or drained of energy too quickly. You can also generate a PDF report, which includes the recommended size, all the electrical load information, and the system components, which you can send to the customer or keep, as well as keep in your records. So on this slide, you can see we have links to the System Estimator itself, as well as to a tutorial video, which will help you learn how to use it. A few resources I wanted to make you aware of. There's a demo of the Enlighten app, which you can access without a login ID or password. So this is great. All you have to do is go to either the Apple or Android app store and download the Enphase Enlighten app, install it. And then when you open up the app, you don't have to log in. Simply scroll down to the bottom and look for this link where it says, or this button, Experience the app. Tap on that and it'll open up a demo of Enlighten. So this is great. Of course, probably doing a lot of virtual consultations still, but if you are starting to get out there and do in-person meetings, homeowners really love being able to see the app live on a phone. If you want to take your knowledge of Enphase products to the next level, I highly encourage you to register for Enphase University online. It's totally free, and we currently have 4 in-depth courses on Enphase storage, sales, installation, and design. And we also have a training program for Enphase solar installation as well. It's really easy to find, university.enphaseenergy.com. You have to have an Enlightened account to log into Enphase University. So if you don't have an Enlightened account, I suggest contacting someone at your company who administers Enlightened Manager, and then they can easily add you as a user and get you access to the system. And a few links to other resources like social media and newsletters are going to be in this presentation. All right, well, that leaves about 15 minutes for Q&A. So I know quite a few questions came in, so let me open up the interface and see what we have here. All right. Nick, you were probably observing some of the questions as they came in. Were there any that you felt I might specifically address first before just going down this list?
Yeah, so there's the first one there, the noise of it, I think is a nice one just to give a comparison to a lot of other backup options that are out there now, generators, things of that nature.
Right, yeah, so as I mentioned, there's no noise from the Encharge because there are no moving parts. No fans, no pumps that are turning on and off to cool the system. So it's a completely silent system. Excellent. And the next question here is, what are the installation considerations, mounting, direct sunlight, placement near meter, etc.? Have we had issues with theft? Well, to answer your first questions, I don't have all the numbers right off the top of my head, but I know if the units are installed outdoors, they have to be installed a few feet off the ground. If they're installed indoors, they can be closer. The units do need to be separated by around 6 inches, meaning the N-Power and the N-Charge units have to be separated a little bit to allow for wiring between the components. As far as direct sunlight, a little bit of direct sunlight in the morning or late afternoon is not an issue. But if they're exposed to direct sunlight for hours at a time, especially in a warm climate, that's going to obviously increase the temperature of the battery. And hot batteries that are above or below the recommended temperature range are going to start to derate, meaning they're not going to be able to charge or discharge at the rates that are stated on the spec sheets. They'll still work. They're just not going to perform as well as they might be needed to based on the kinds of loads that the customer has. In general, in any climate in the U.S., even very cold climates, if the batteries are installed inside in a garage, they're going to be fine. But in very cold climates that are we're below freezing for many days in a row, we don't recommend installing the batteries outside in those climates. I haven't heard any issues with theft so far. I mean, our batteries haven't been out for decades, but they have been out for about 1.5 years, and I haven't heard about one instance of theft. Next question is, you compared the N-Power to the Tesla Gateway. With the Gateway, you're able to migrate up to 6 backed up loads. Is that possible with the N-Power? So that's something that I'm not familiar with. I might need some clarification from you on what you mean by migrate 6 backup loads. Do you mean that you can actually control the loads like we can with our load control feature? My understanding with the Tesla Gateway, you can connect a single thermostat wire into the gateway, which allows you to basically control something like an air conditioner or heat pump. But to my knowledge, it was just a single device. So maybe you could clarify on that. So next question is, what about a refrigerator? Would you run that on an Encharge 10 kilowatt hour? Yeah, absolutely. An Encharge 10 can easily run a standard refrigerator. If you were powering multiple refrigerators that could potentially turn on at the same time, you might want to take a look at use the Enphase system estimator and put in the specs of those refrigerators to make sure that it could do it. But yes, certainly one refrigerator is very standard appliance to pair with a single Encharge 10. Next question, can the Encharge provide the 60 Hertz signal needed to keep the Enphase microinverters running during an outage if the sun is still out, or at least just charge the battery system during an outage? So yes, that is what I mean when I say the Encharge forms the microgrid. That's exactly what they're doing. So the IQ8 microinverters, which are our next generation microinverters inside the Encharge batteries, they are what are called a grid forming microinverter. And they can do that in a way that our previous generations cannot do. So basically, during a grid outage, the IQ8s create that 60 Hertz signal, and that tricks the microinverters into thinking that the grid is stable. Basically, they think they're connected to the utility grid, and the microinverters function normally, which allows them to charge the battery when the system's disconnected. Next question is, can you configure 3 Encharges to work on a 3-phase system, since there are 3-phase Enphase microinverters? I don't believe so. I don't. That would be a good question for one of our technical trainers. Nick, I will try to get that answer and get back to you if you want to respond to that particular question.
Definitely.
But I'm not pretty sure that's not possible at this time. Or another way to put it might be technically possible, but it's not something that's supported by Enphase as a manufacturer. Next question, with circuit control, do you control which modules stay off, such as one section has shade on the roof at a certain time of day? Well, I believe you're talking about PV circuit control. So the PV system is going to be divided into multiple branch circuits, which are connected into a circuit breaker. So basically, with load control, you're going to install another device called a contactor before that circuit breaker, and that's going to disconnect that branch circuit. So just to be clear, we're not turning off like individual solar panels based on shade. It's simply controlled at the level of the branch circuit. So when you're setting the system up, you get to choose which branch circuit you want to be disconnected. So, thinking of the issue of shade, I think if I was doing it, and if there was some shade on the roof that happened to occur in the afternoon, when you really want the system to be cranking and making sure that battery is topped off, I would probably have that branch circuit that's more impacted by shade be the one that's disconnected during a grid outage.
I think that was all the questions in the chat. There's a number of other ones inside the Q&A section. I don't know if you have that pulled up on your end, but the first set is about compatibility with older Enphase systems, so M215s, M250s, IQ6, 7.
Yeah, so let me see. Oh, I see. So that was just the chat that was coming in, not the Q&A. So great, lots more questions here. Okay, so yeah, first question I see is from Nicholas Carter. Can you mix the M215s and IQ8s on the same PV circuit when installing Encharge? So no, unfortunately, you can't intermix those two systems. The power line communication protocol, the wires that are used for PLC are different between the M215s and the IQ8s. So it needs to be all in the same ecosystem. And I'm rereading your question. So you mentioned the IQ8s. The IQ8s currently are only available in the battery storage system. So obviously we are saying you can combine M215 solar microinverters with the battery system that has IQ8s. But combining M215s with IQ series of any type is not possible on the solar array. So, in time, obviously, you're aware that we're developing the IQ8s for solar. So once those are on the market and available, you would not be able to combine those with M215s in a storage system for the, on the solar part. All right, and I think I answered the next question, or IQ6 or IQ7 for that matter. Yeah. Okay, next question is, can the created brownout damage compressors or motors? So yeah, you're talking about the power start feature, the brownout. My understanding is that it's so brief, and it's also within what's considered the acceptable range in terms of safety for homes, according to the NEC, that there's no risk of it causing any damage. Okay, next question. Why replace the entire battery if only one micro fails? So you might have misunderstood my description there. So if one micro fails, then the battery still functions. The power output is going to decrease proportionally compared to the number of micros that are failing. So the example that I had was if 1 out of 12 micros fails, the battery can still produce 92% of its power output. And then once that one microinverter is replaced, it'll be back up to normal again. And that's something else that I might not have mentioned, but our system is field serviceable. So if a microinverter fails, you can take a new microinverter out, pop the cover off, replace the microinverter, kind of like changing an ink cartridge in a printer, and commission it with the Installer Toolkit app within a few minutes, and you're back up and running at 100%. So the battery does not have to be replaced if a microinverter fails. That's one of the big benefits of our system, is that it's field serviceable. Okay, another question here. Generator availability. I'll have to get back to you with the most current dates. I don't want to give you an incorrect date here. I'm not too current on that, but I'll get that to you, Nick, so you can reply later.
Yep, that's perfect. And all the questions, just for everybody in here, if we don't have an answer, we'll have a report, your contact information, so we can follow up with you afterwards.
Next question, which he says, sorry, I missed it. Might have been mentioned at the beginning. When incorporating the Encharge storage system, a cell modem IQ combiner is required. So yes, technically the cell modem is required. So there we have a model of the IQ combiner. I'm drawing a blank on the model number. Nick, you probably know, but the IQ combiner sometimes has a cell modem built into it. So you can get the model that has the cell modem for new installations, or if you're retrofitting a system from a couple years ago that doesn't have the cell modem, you just have to buy the cell modem separately and install it in the IQ combiner and plug it in.
Yeah, and there's two different versions, and you can see them on our website. One that has the cell modem, it's just a same part number, but with a C, I believe, incorporated.
That's right, IQ combiner C.
Yep. So.
Okay, what's the max size generator that the smart switch will accept? Let me quickly pull up some notes I have on generator integration to answer your question there. Okay, bear with me for a second. Okay, so I've got a list of generators that I know that have been tested with our system, and they range on the small side at like 11 kilowatts up to 19.5 kilowatts. I believe that generators that are over around 15.5 kilowatts are not ever going to reach their full power output capacity because of the fact that the circuit breaker that the generator is connected to in the end power is 60 amps. And that's going to be the limiting factor. So if the generator attempts to push more power into the end power, then that 60 amp circuit is rated for, just 60 times 0.8. 48 amps would be the maximum. So yeah, you can install a larger one, but it's not going to ever put out its full power because of the limiting factor of that 60 amp circuit breaker. We do have a preliminary tech brief, which goes into great detail about generator support, so I'll make sure that you have that, Nick, to share with the group. So this is kind of a question for RENVU. Can you compare a standalone PV system with Enphase versus SolArc?
Yeah, I believe we actually have a comparison chart that we can send over already made up in our Learn section on our website, so we can touch base with you afterwards, Richard, and do that. And we're also happy to talk with you as well about specific situations. So.
All right, next question is, can the smart switch be used with string inverter systems and a generator? So no, the smart switch is only compatible, only supported by Enphase for use with our the Encharge batteries and Enphase microinverter systems, not any other equipment. How does storing your own battery power affect putting power back in the grid by earning negative kilowatt hours to offset usage in the winter months? So the battery, depending on what mode it's operating in backup priority mode, the battery doesn't do anything, just sits there and waits for a grid outage. The other mode, probably the most common setting, is savings mode. So savings mode, you can program the battery so that during the times of the year when rates are more expensive during different times of the day, you can program the battery to basically charge up during the off-peak or less expensive period and then discharge into the home during the peak period to save money. Now, even if you're in savings mode, you still want to take advantage of net energy metering. So for example, during the off-peak period, once the battery gets completely, fully charged, excuse me, once it's fully charged, you do want that excess power to go back to the utility grid to earn your credit. But because it's the off-peak period, you're not going to get as high of a credit. So essentially, you're still taking advantage of net metering, but with the battery, you're able to kind of game the system with what we call in the industry rate arbitrage by buying low and selling high in a sense. So hopefully that answered your question. I live in Wisconsin. My Encharge 10 will be installed next week. It needs to be installed inside the garage because of the severe cold we sometimes get. We also get some real heat here. What kind of heat could I see in the garage from one Encharge 10? As an Enphase stockholder, I'm very pleased to be an owner as well. Excellent. So I think you're asking what kind of heat an Encharge 10 would generate. I've never been asked that question before. I mean, the efficiency of the microinverters is kind of going to determine part of that, as well as the batteries themselves. I'll have to get back to Nick on that and see if I can find an actual number. But I think it's such a small amount that compared to the amount of heat that's coming into your garage just from the ambient temperature outside and the sun is going to be pretty insignificant.
To kind of piggyback up, this was, I think, another question that was asked earlier too. I think sometime next year there's going to be an NEC update that requires all batteries to be located outside. I don't know if that was addressed earlier or not, but yeah, I guess, do you have any insight on that and maybe plans for what's going to happen down the line?
Yeah, that's the first that I've heard of it, Nick. So I'm sure that our engineers are aware of that and are taking that into consideration with future iterations of our products. Okay, next question is total transfer time in case of grid power loss. I only heard the operation time for the switch, but how long before the microinverters have the microgrid up again? So switch. So the microinverters actually are able to respond much faster than the switch. The switch responds in 12 to 15 milliseconds, but the microinverters have microprocessors that are built specifically for this application, and they actually respond much more quickly than the switch itself. So yeah, the limiting factor, or what determines the speed of that actual physical connection and reconnection, is the MID that of the N power, not the microinverters. But yeah, I don't have a specific answer, but we're talking about I think it's sub 1 millisecond. We're in the nanosecond range for the microinverters to form the microgrid. Next question, will this work for off-grid? I have a construction trailer that I can put solar on with Enphase and add a few Encharges for AC, fridge, and lights. So our system, it has to be connected to a utility grid in order for it to be commissioned. That's just a hard stop right there. There might be future iterations where it can be used on a completely off-grid situation. But again, just to be clear, in order to actually commission the system, get it turned on and fully functional, it has to have the ability to connect to a utility grid. So another question, what is the power quality of the Enphase backup system with generator spikes? I'm not even going to try to fake my way through that one. I don't know. I think again, kind of going back to the speed of the microinverters and the battery storage system, because they can adjust extremely quickly. If there are fluctuations with the generator, those microinverters are going to detect that and react to that very quickly for a decent power quality. But yeah, that's kind of the best answer that I can give to you for that one. Okay, what's the maximum discharge of the battery? So I think you're talking about the power output. So it depends on what combination of batteries you're using. The Encharge 10 has a continuous power output of 3.84 kilowatts and a peak power output for peak power of up to 10 seconds of 5.74 kilowatts or 5.76, somewhere in that range. So the peak power is 50% higher than the continuous power rating. What's the maximum? Okay. Next question is a little confusing. I had to replace the entire battery 6 weeks ago. Since when? Maybe you can clarify. I'm not sure. You might be following on to a different question placed earlier, so maybe you can just clarify that one for us. I received conflicting info on replacing battery inverters. I was told by support that they're not replaceable, which is true. So that's news to me, Peter. I'm surprised that you heard that from support. I'll have to check on that. I mean, my understanding is that the system is designed so that those microinverters are field replaceable. So yeah, I apologize for that. I'll have to get back to you. Okay, question, why is the cell modem required for the system? The cell modem is required really just to improve the customer experience. We found over the years, and from just knowing what kind of issues have happened with other energy storage systems on the market, oftentimes a home is a battery system that's connected through either Wi-Fi or basically it's connected through the home's network, oftentimes loses power during a grid outage. Even though it's usually the intention to connect the network equipment to the backup power system, to the partial load subpanel or backup load subpanel, sometimes things are missed. Sometimes the ISP has a device that needs to have power and it loses power. So essentially the cell modem there is as a backup to the hardwired or the permanent network internet connection at the home. And I understand this is a kind of a point of frustration for some because sometimes systems are installed in kind of remote areas where cell service is weak and it does seem like a waste. I understand the frustration there, but the purpose of it is so that the vast majority of our customers that are actually not in remote areas do have that backup internet connection, so they can always see energy consumption. I'm sorry, always see the details of the system, monitor their system, and be able to control it.
Real quick, just jumping here, Tony. I think maybe we'll grab two more since we're pushing over time. So we can just go through here and maybe I'll pick out two questions and then we'll go and wrap it up. Any of the other questions that we don't get to, we can touch base with everybody afterwards about them. But maybe we can jump to Roger's question. When installing 3 or 4 Encharge 10s, can they be split up due to wall space? And if so, is there a max distance that's allowed between the units?
Yeah, absolutely. They can be split up. The distance, the maximum distance between the units is going to be based on the recommendations for the wireless communication kit. So remember that wireless kit that's inside the IQ combiner, you want the Encharge units and the Npower to be relatively close. I think we say something like 50 or 60 feet if in line of sight. So you don't really want to put one battery in the garage and then another battery 50 feet away on the other side of the house, because that's going to negatively impact the wireless communications. But inside a garage, put 2 batteries on one wall and put 2 batteries on a different wall, absolutely no problem at all.
Excellent. And then maybe I know you talked a little bit about it before, but maybe we can just recap and retouch base on it. For Richard, is there a future method being designed? Do you know if there's anything for off-grid? Do you know if there's anything currently in the works that's going to be designing to meet that? I know that there's backup system design with the IQ8 where it can be functional without batteries, but is there anything where it's going to be designed for full off-grid?
Yeah, not that I know of. I know it's been talked about, but it's certainly not something that I've seen on any kind of timeline that we're developing it. So it's a possibility. I just would not make any plans based on that.
Excellent, cool. Well, I think we can go ahead and wrap up there. The remaining questions that we've got in there, we'll touch base with everybody afterwards and try and get those answered as best we can. If you have any questions that you didn't have or if they come up later as you're thinking about it, feel free to email us at info@renvu.com and we can help out as best we can and reach back out to Tony or anyone at Enphase if we don't have the answers. So I just want to thank you again, Tony. It was great to have you. Great presentation. I want to thank everybody for joining. And yeah.
Cool. Thanks for having me.
Excellent.
Enjoy the opportunity.
Yep. Sounds good. All right. Thanks, everybody. And we'll see you all again soon.